Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lecture, we had discussed about Dalton's atomic theory. Today we will discuss these postulates in details and we will study about their drawbacks. So let's start. Dalton's atomic theory was proposed by John Dalton in 1808. Okay, so we had enlisted these postulates which were the part of Dalton's atomic theory. So the first postulate was matter consists of indivisible atoms. So Dalton said that every kind of matter that is present in the earth or in the universe are made up of very small particles called atoms which are indivisible, that is cannot be broken into further smaller parts. Okay. So he said that the atom cannot be broken any further. These are the smallest constituent of matter. The second postulate said that all atoms of a given element have identical properties including identical mass. Atoms of different elements differ in mass. So, all atoms of a given element have identical properties. So, this was a very important concept of Dalton's atomic theory. For a given element, all atoms of a given element which is available throughout the earth will have identical properties and they will also have identical mass. Whereas he said that for different elements, their atoms will be totally different. Their properties as well as mass will be different, differ in mass and properties. Okay. And the third postulate said that compounds are formed when atoms of different elements combined in a fixed ratio. Okay, so this is clear that his concept was that when molecules form, that is when atoms of different elements combine, they do so in a fixed ratio. And the fourth postulate said that chemical reactions involve reorganization of atoms. So, in Dalton's atomic theory, there was no concept of chemical reaction. Okay. So, he only said that chemical reactions are reorganization of atoms. So, now these theories, as it can be understood, that these theories are quite different from the modern chemistry that we know today. So, obviously, Dalton's atomic theory had certain drawbacks. We will now see what were the drawbacks of Dalton's atomic theory. So, okay. So, the first drawback was, see, the first point said matter consists of indivisible atoms. That is, according to Dalton, atoms were the smallest part and atoms cannot be divided further. But now we know about subatomic particles. So, the first drawback was Dalton did not account for the presence of subatomic particles such as protons, electrons, neutrons, etc. We know that there are various subatomic particles such as protons, electrons, neutrons, neutrino, positron, etc. There are numerous subatomic particles. But according to Dalton's theory, if atom is indivisible, that is, if atom is the smallest part, then these subatomic particles shouldn't exist. So this was the first drawback, that Dalton did not account for the presence of subatomic particles such as protons, electrons, neutrons, etc. The second drawback was that in the second point, Dalton said that all atoms of a given element have identical properties and atoms of different elements had different properties. But we know about isotopes and isobars. So, isotopes and isobars were not explained. So, we will discuss about isotopes further in this chapter. So, isotopes are the atoms of different elements which have the same atomic number but different mass number, such as say carbon 12 and carbon 13. Both of them have atomic number 6, but they have mass number different. That is, one type of carbon atoms have mass number as 12 and a different type of carbon atom has mass number as 13. They are called isotopes. Similarly, there are isobars also. Isobars are different elements. So, they have different atomic number but they have same mass number. For example, argon and calcium. So, argon also has mass number of 40 and calcium also has mass number of 40. So, they are called isobars. But according to Dalton, if same elements had similar atoms, that is identical in properties and mass, and different elements have totally different atoms which are different in mass as well as properties, then isotopes and isobars cannot be accounted for. So, this was the second drawback. The third drawback of Dalton was this theory does not give any idea on formation of molecules and it could not explain the laws of chemical combination. Okay. So, Dalton did not give any idea about the formation of molecules or formation of chemical bonds. He said in the last postulate that chemical reactions involve reorganization of atoms. But for the formation of molecules, always reorganization is not sufficient. We need to have some kind of chemical bonds. But Dalton's atomic theory did not give any explanation on the idea of formation of molecules and also no explanation on bond formation. Okay. So, and also the laws of chemical combination that we had studied earlier were not explained by Dalton's atomic theory. Also, there was another drawback that Dalton said compounds are formed when atoms of different elements combine in a fixed ratio, but not all molecules have fixed ratio of elements. All molecules do not have fixed ratio of atoms. Okay. So these were the drawbacks of Dalton's atomic theory. Now, although these were the drawbacks, and after that various subatomic particles were discovered one by one, and there were many other atomic theories like Rutherford's, Bohr's, and quantum mechanical theory. There were a lot of atomic theories. We will not study them in this chapter, but now we will study about atoms and atomic mass. Okay. So, we know about atoms, and atomic mass is the mass of an atom. Mass of an atom is defined as the mass of protons plus the mass of neutrons, that is the mass of the nucleons. So, an atom is represented as spherical for convention. Okay. So now we are going to discuss about atom and atomic mass. Okay. So conventionally, atoms are considered to be spherical in shape. Okay. And the size of an atom depends on the radius of atom. Okay. So an atom is represented like this. Okay. So if this is some element, this capital A represents the mass number, and capital Z represents atomic number. So atomic number is written at the bottom and mass number is written at the top. So this is the representation of an atom with its mass number and atomic number. Now, what is atomic number and what is mass number? So atomic number is the number of protons present in an atom. Okay. So, by definition, atomic number is the number of protons present in an atom. This is also equal to the number of electrons present in the neutral atom. Neutral atom means there is no charge. Okay. So when there is no charge on an atom, the neutral atom contains equal number of electrons and protons. This is called atomic number. Okay. So neutral atom contains equal numbers of protons and electrons. Okay. So this is the atomic number. Now mass number. which is represented by capital A. So, mass number is the total number of protons and neutrons present in the nucleus of an atom. So, mass number is the total number of protons and neutrons present in the nucleus of an atom. Okay, or the sum of the number of protons and the number of neutrons. Let's say if we consider number of protons is equal to P, number of protons equal to P, number of electrons equal to E, and number of neutrons equal to N. Then atomic number Z is given by P, which is equal to E. That is, atomic number is equal to the number of protons or the number of electrons. And mass number A is given by P plus N. That is the total number of protons and neutrons present in the nucleus. So, this is the mass number. Now, we will see certain general informations about electron, protons and neutrons before discussing atomic mass in details. So, electrons, proton and neutron. So, this is a comparative study between these three subatomic particles. Okay. So, the first of all, charge. Okay. Electron is negatively charged. Okay. So, electrons are negatively charged, whose relative charge of one electron is -1, and the accurate charge is -1.6 into 10 to the power -19 coulomb. Protons are positively charged. And the relative charge of one proton is +1. So, in terms of charge, protons are exactly the opposite of electrons. Therefore, electrons and protons balance each other and maintains the neutrality of an atom. The charge of a proton is plus 1.6 into 10 to the power -19 coulomb. And neutrons have no charge. So, neutrons are neutral. Their charge is equal to 0. Okay. The mass of electron, mass of one electron is equal to 9.1 into 10 to the power -31 kg, or 9.1 into 10 to the power -28 grams, or in AMU it is written as 0.000548 AMU. We will read about the definition of AMU later on. For protons, the mass of one proton is equal to 1.673 into 10 to the power minus 27 kg, or 1.673 into 10 to the power minus 24 grams, or 1.007 AMU. So, the mass of one neutron is equal to 1.675 into 10 to the power minus 27 kg, or 1.675 into 10 to the power minus 24 grams, or 1.008 AMU. So, this was the comparative study between electrons, protons and neutrons. Thank you.